This is higher homework. It's practice paper C, and we're looking at question 2 in the calculator paper. And this one here looks like a vectors question, calculating the size of an angle in 3 dimensions. So we'll go ahead and we'll do this question here. Right, so part A. Okay, I can see the diagram I have here. I can see that OA is 8 units long, OC there to there is going to be 5, and OD is 7. Okay, so the height of it's 7 all the way around. Okay, right, so all I've got to do here is write down the coordinates of B and G. So let's look at B first of all. Okay, so for B, B's over here. So B would be 8 along the way, and it would be 5 that way in the Y direction. I'm just seeing the 5 there, and it's got no height to it. So that would be 8, 5, and 0. What I'll go for is the next one would be G. And for G, what we're looking at is G is up here. So G is 0 along in the X direction. It's 5 in the Y direction. And it's 7 high. So it's 7 up in that direction there. Okay. And let's see, I think another one that I'm going to need here is going to be, I'm going to need E when I start in question part B. So the angle that I'm really interested in is the angle that looks as though it comes from BEG. So that would be from B up here to E, and then along there to G. Okay, so that's really what I'm after. And the vectors that I'm going to need are the vectors that point away from the angle that I'm interested in. Okay. So if I draw that out just here, just as a basic, very, very simple diagram, what I've got there is I've got the size of angle BEG. So I'm going to start with a B here. I'm going to come to the vertex there with an E, and I'm going to go there with a G. So remember, if it's this angle here that I'm interested in, I need the vectors that point away, and this is really important. So I usually draw this small diagram there just to try and make sure I keep things right. So what I'm going to do is I'm going to just write down the coordinates of E first of all to make sure I've got that, because I'm going to need to use that, I'm sure, once I do the working for this. So E is going to be 8 along that way in the X direction, 0 in the Y, and it's going to be up 7. So I'm going to go for 8, 0, 7. So that's going to be E. Right, so let's go ahead and work out the size of the angle. So I need the vectors. So the first vector I need is going to be EB. Okay, and the way I'll work that out is the position vector B minus E. Okay, and what I've got is 8, 5, and 0. And subtracting from that should be 8, 0, and 7. From that I should have 0, 5, and minus 7. So that's EB. Next one I need is E to G. So let's work that one through there. So from E to G, what we'll go for is G, subtracting E. And same kind of setup that I have here. And what we'll do is I'll work out what that vector, that column vector is there. So 0, 5, 7, we'll go for here, just taking it from G, and for E, I've got 8, 0, 7, and just subtracting them, that'll give me minus 8, that'll be 5, take away 0 will give me 5, and 7, take away 7 will just give me 0, so that's the column vectors there. Okay, so from here, what we'll do is we'll then work out the size of the angle BEG, and from the formula list you'd be able to work out how to write the formula for this one. So it's going to be cosine of the angle, and it's BEG. And what we've got on the top, we've got a scalar product, and the scalar product is going to be these two vectors that we've just worked out, dot product, over the magnitude of the vectors. Okay, so from there what we'll do is we'll work out the dot product first of all, okay? And I'm just going to keep all of this together just in the one large calculation. So all I'm going to use is these column vectors and multiply them out to find the dot product. So I've got 0 times minus 8 plus 5 times 5 plus minus 7 times 0. That's my top line. From there I'm going to work out two square roots, and these are going to be the magnitudes of the vector. So it's going to be 0 squared, it's going to be plus 5 squared, plus minus 7 squared, and for this vector here it's going to be minus 8 squared, plus 5 squared, plus 0 squared. Okay. So from there on the numerator I've got 25, and I'm going to work these two out there, so I've got 25 and 49, so that should give me 74. And from here I've got 64 and I've got 25, that should give me 89. Okay, so that's the cosine of the angle is equal to this part here. So what I'm then going to do is I'm going to say that BEG is going to be equal to the inverse cosine of 25 all over root 74 times 89 on the denominator. Putting that into my calculator, what I should get out is 72.0579 and some more numbers from there, but rounding it to one decimal place, that should give me 72.1 degrees, and that's to one decimal place. And that would be that question there complete. Let's have a look quickly at the marking for this one. So what I'm going to go for in part A, 2 marks, so obviously the only things we've got, 1 mark for each of the coordinates of each of these points here. What I'll then go for is, I'll go for 1 mark for getting both of these column vectors together. I'll take 1 mark for setting up this equation correctly here. 1 mark for working out the dot product. A mark each for the magnitude of these, so that's 1, 2, 3, 4, 5, and finally 1 mark for stating the angle that's left there. So 6 marks for part B, 2 marks for part A. Question out of 8 marks.